Swayam Prabha. Digital India. Educated India.
Is it okay? Were you able to follow what was happening yesterday? Okay. Okay. So today I think, as in yesterday, we were talking about, I would say, inspiration from neuroscience and learning, and we are trying to look at algorithms that underpin the brain's function, and so we wanted to kind of see what are the mathematical principles underlying any of this processing. So so we took one example and saw how the one example, I would say in that one example, what are the underlying mathematical principles, at least for coding, and we saw the sparse coding as a principle. And then I said there are a lot of other things like processing, I would say simplicial structure in the network, all of which basically is, as in, I think we don't really understand how that happens, and kept it open, and it's an open area for research. In some sense, today we'll switch gears actually. We'll switch gears a very different direction. But I would say game theoretic ideas have been used in learning before. I think there's something called generative adversarial networks where it is game theoretic formulation. And so game theory has some role to play in learning, but we will not get into it today. How many of you heard of game theory before? Okay. So what do you understand by game theory?
It's study of games. So like games, there's a couple of categories that we have, like multiplayer games, games with complete information.
Yeah. So have you done any work on it? Have you studied before? No.
I tried reading a book, I got 5 pages.
Okay. We'll do a lot of games today. And yeah, what about you? Somebody was raising a hand here. So what do you understand by game theory?
Basically studying the psychology behind how the characters in the game work, what are the win conditions, applying it in theory.
Yeah, so I think both of you are right in that. So basically, there is some kind of a structure basically, and there's some players, and then they have some kind of a strategy, and they have some incentives, and they have some goals. And so to reach those goals or to optimize those goals, they try to kind of pick some action out of which there's an outcome. But psychology plays a lot of role. They're also thinking what the other person is doing and so on and so forth. But I think before we dive deep into, or basically at least even look at the examples of game theory, what we'll do is basically, let's try to see, I'd say, what's the difference between game theory and anything that you learn in engineering. In engineering, what tends to happen is, let's say you're talking about, let's say, some equations in physics, like gas molecules. You actually tell me how the pressure is or temperature is and things like that. I can tell you about the behavior. If you tell me basically the temperature of the water in this pipe is, let's TH, which is high, and then the water in the lower pipe is T low, and then you say I'm going to mix this, and then you know what you can predict basically just using the laws of physics. What will be the final temperature? Because you say its entropy is going to go up, and then whatever is the highest entropy, that's the state the system settles. So there's all these notions about, I would say, molecules satisfying, I would say, kind of, let's say if there's a high pressure and a low pressure, then I would say those things dictate how your molecule moves. So now what happens is, what if the molecule had its own thinking, like it can think and say, oh, I'm going to go there if you do this for me, or if things like that. As in molecules don't have, but if you actually replace the molecule by an agent, which can actually reason, and I would say I'll do this if this happens, and things like that, what do you get? You get a very different system actually. And then in this particular system, it's more like the system that you're actually living in, because most of the times when you're doing something, you're seeing what the other person is doing. Let's say in football or something. Depending on where the ball goes, you do, or who the player is, you actually kind of try to, I would say, adapt the way you ball to the batter and things like that. So what happens is, there's a lot of, I would say, strategic interplay. What you do is you try to guess what the other person is doing, and then you try to react to it. Your molecules don't do that, right? They actually kind of say, okay, this is the setup. If this is the pressure, this is what I'm supposed to do by the laws of physics, and they follow. But they don't try to reason what the other molecule would do or what something else would do. So it just looks at, so there's always, and depending upon one player, the other player also might change his strategy and so on and so forth. So there's all this interplay. So, so that's similar to physics, I would say. I'm not saying it's same, but I just want to kind of say, basically, let's say you actually have some structure like this. Let's say basically, and you drop a ball here. So what will be the final state of this ball? If you give infinite time, where does it settle down? Yeah. So in ideal case, it will keep going, but in a real case, what happens is because of the friction, it settles down here. And basically, this is more like an equilibrium point for the ball. So, the reason is basically, and it's a stable equilibrium, because basically, if you disturb it slightly, if you perturb it slightly, it will come back. But then, if you actually have something on a maxima like this, then that's also an equilibrium point. But at that point, basically, if you disturb, it's gone. It's unstable equilibrium. So, this in some sense, this is the final resting state of this. And then, if you actually kind of perturb it, will come back. So basically, that is it enforces that equilibrium and stable. So you have notions like this in games also. Once you write a contract, nobody has incentive to deviate. Nobody will deviate once you kind of get logged into a contract. We'll see that. Similarly, when you actually have dynamics, let's say you have let's say some conditions, and then you actually have some gas molecules here. What tends to happen is, let us say, let's say you have two streams, let's say a TH, TL and things like that, and you mix them. Once you mix them, it will reach some temperature, let's say TC or something. Once it settles that into the state, it will remain at TC. There's no fluctuations. But in the meantime, what happens is, as this whole thing is happening, there's some dynamics that it goes through. Similarly, what happens is in games also, when you actually kind of let, I would say, some two players, a couple of players start playing the game, what tends to happen is one player plays, the other player plays, the other player plays, and so on and so forth. And these dynamics are very similar to the dynamics in, I would say, in like physics, but they don't follow the same laws. They also have dynamics. At the end, all of them are trying to reach some state of, I would say, sometimes basically it's maximum entropy state in physics, but here it might be something else. And there's no one fixed state, there might be multiple states that the system can go. And so we are actually talking about, like, for example, what is the final resting state that it will go, and how the dynamics will go. We'll actually talk about it. But the notions of metric, like the way you have in physics, that are not applicable here anymore. So you actually go into a very different regime. So first thing is, the agents, like molecules, do not have an agency. They cannot think by themselves and take autonomous actions. But here they take. And then basically what you also want to see is, basically, in engineering systems, generally game theory was not a part of engineering curriculum, but it becomes important now. This is mainly, earlier it was in the domain of economics, diplomacy, public policy, and auctions mostly. But now what's happening is, people realize the need for game theory in engineering. Why? Because you have these intelligent agents, everybody has some bots, and all these bots can take autonomous decisions. And now when all these bots are actually doing all the decision making, then I would say it's not the same dynamics. Partly they follow some physical laws, but all the strategic decision making happens through game theory. So it becomes important now. So that's the reason why I think even engineers should be aware, and a lot of computer scientists, and for example people in robotics and autonomous agents basically, and for example multi-agent systems, actually use game theory to be able to craft algorithms that are actually trying to achieve specific goals. Okay, any questions? Is this setup clear? This setup is it's a significant departure for anything that you have done before in engineering or physics. That's the bottom line. It's mainly used in economics, where agents can take decisions. That's where we start off. Let's move on. So what I'll do is, today I'll actually play you a few videos here. I'll play two videos before we kind of go into any of the, I would say, are actually trying to work out something. And what I want to do is, basically, we'll try to analyze what's happening. We'll take these videos, we'll draw the games for them, we'll do an analysis of what's happening in these videos. Second, so then we'll actually we work out some of the games to kind of point out some kind of ideas in game theory. And then I told you about this equilibria. I'll talk to you about equilibria, and specifically I'll talk to you about something called Nash equilibria. How many have heard of Nash equilibria or John Nash? Sorry? Sorry?
Just like the statement, neither player can get any better than the position they're in.
That's right. So basically, I think so. Nash equilibria is a very central idea in game theory, and he got a Nobel for it in 1994. So we'll actually look at Nash equilibria, and as a Nash equilibria has deep connections with topology, basically fixed point theorems. So because he uses fixed point theorem to prove the existence of equilibria, so we'll actually briefly touch upon equilibria. We'll touch upon other equilibria called correlated equilibria, which you always use when you are actually at traffic signals, but you don't know how it works. But basically here we'll actually I'll just show you a game of how it works. Then we'll actually, okay, now we have actually done some games, small games. Now what we do is we'll see applications in auctions. As in how does auctions work, and why is auction even conducted, and what can happen in auction basically. And actually auctions are all over the place. When you're actually using your cell phones, the spectrum has been auctioned. In the sense, basically, you heard of 4G spectrum auction, 3G spectrum auction. There's also scams and things like that. That's controversial. Let's not go into it. But then, following the auction, there's IPL auctions actually. How many of you heard of IPL auctions? Yeah. So I think that's very popular because basically, I think at this point of time, I think auctions. Why are auctions so important? They're so central. Every day in the newspapers, you see something is being auctioned. Auction is something basically you're actually taking one good, some kind of a thing. So let's say you have maybe a player, for example, Pat Cummins or something, and then you don't know what his worth is. So basically, you put him in the open market and let market decide the price because you have no gauge of it. So now what you do is basically, you kind of try to construct the auction in such a way so that it realizes the price. Sometimes it might be your objective might be, I would say, profit maximization. Companies try to do profit maximization. But governments, what are governments? Governments are meant to do welfare maximization. So government will have another objective. So depending on different objectives you have, you'll use game theory to craft different kind of mechanisms to enable this to happen. And then we'll actually see something called price of anarchy. I'll show one example in which basically whatever you actually wanted, let's say you want a social optimal, what is good for everybody, is not what happens in the society. What is good for everybody in the society is actually basically might be very different from where your equilibrium converges. Your systems will converge to one point, but then that is disastrous. So we will see one example of it, and all these are more like, I would say, toy examples, but all of these examples will apply to public policy and social welfare and lot of, I would say, lot of aspects of life that actually in your life they touch a lot of aspects of life, but probably we are not aware of it. But we'll actually go through all of this today over about like next 2 hours or so. Questions? Okay, then shall we get started? I'll play the video. Be very careful when you're listening. So I think if I play the video, with the audio come here? Does the audio come here? Let's not sure. Let me see if does the audio come, or audio can I play? No, I think the audio is not coming. Audio should be. Shall I put the mic here? I can put the mic here.
Final winning golden ball for today is
Feedback.
final winning golden ball for today is how many times?
Maybe this one.
Welcome back to Golden Balls. After a run of big cash balls, Ibrahim and Nick now have 13,000.
Is the volume? Are you able to hear what's happening? No, you're not able to hear.
Welcome back to Golden Balls. After a run of big big cash balls. Ibrahim and Nick now have £13,600 in front of them. We know they've got it, but the golden question is, can they keep it? Ibrahim and Nick, you now face a very straightforward choice, but it's a choice that could make one or both of you extra wealthy, but it could also lose both of you everything that you have fought for today. They have to decide to split or steal. Ibrahim, Nick, you have two final golden balls in front of you, and they are the most important golden balls of the game. You each have a golden ball with the word split written inside. You both have a ball with the word steal written inside. You will know which is split and which is steal because you can have a look. If you both pick the split ball, you split the 13,600 and you go home with 6,800 each. If one of you chooses the steal ball and the other chooses the split ball, whoever chooses the steal ball goes home with the whole lot, 13,600. But if you both choose the steal ball, you leave today's game with what you came with, nothing. It's the ultimate test of faith, trust, and let's face it, greed.
Are the rules of the game clear? What's happening? So, okay. Let's start it.
Take a moment to look at the balls in front of you so you know for definite which is split and which is steal, but obviously keep them concealed from each other. Just have a look. Okay. It's the easiest choice, but the most difficult one. What I want you to do is to spend half a minute talking to each other about what you both should do. Nick, Ibrahim.
Ibrahim, I want you to trust me. 100% I'm going to pick the steel ball.
Sorry,
I'm going to choose the steel ball.
You're going to take
I want you to do split, and I promise you that I will split the money with you.
Well, after you've took the steel.
Yeah.
You're going to take steel.
Yeah.
I'm going to take split.
Yeah.
So you take the money.
And I will split it with you.
After the show.
It's okay. It's not coming. Okay, I think let's.
If you do steel, I'm going to choose the steel ball.
You're going to take.
What you both should do. Nick, Ibrahim.
Ibrahim, I want you to trust me. 100% I'm going to pick the steel ball.
Sorry,
I'm going to choose the steel ball.
You're going to take.
I want you to do split, and I promise you that I will split the money with you.
Well, after you've took the steel.
Yeah.
You're going to take steel.
Yeah.
I'm going to take split.
Yeah.
So you take the money.
And I will split it with you.
After the show.
Yeah. Ibrahim, I promise you I'll do that. If you do steal, we both walk away with nothing. I'm telling you 100% I'm going to do it.
I appreciate that. Right, I'll give you another alternative. Why don't we just both pick split?
I'm not going to pick split. I'm going to steal. Ibrahim, honestly, 100% I'm going to steal.
It's in your nature to steal.
No, I'm honest, and I'm going to tell you.
You're
that
an honest
I am. That's why I'm telling you I'm going to steal. If you do split, then I will split the money.
I can't see myself doing that.
Okay, well, I'm going to steal, so we're going to leave with nothing.
Where's your brains coming from? I can't work out.
I know that I'm a decent guy, and I will split the money with you.
Well, we should just both split then.
No, I'm going to do steal.
There is no legal
I know there is.
for him to give you the money.
Of course. If I gave you my word, now let me tell you what my word means.
Okay.
My father once said to me, a man who doesn't keep his word is not a man. He's not worth nothing. Not worth a dollar.
I agree.
So
Ibrahim, I'm going to steal. So you've got the choice. You either steal, and we both walk away with nothing, because you know I've told you my intention.
Let's pause. What do you think about the brown guy? what do you think about the brown guy? Is he doing the right thing? The brown guy, what is the brown guy saying? He said steal, as in whatever you do, I'm going to steal. Do you think what he's doing is right? Let's see.
I told you that I would split the money with you, Abraham.
If I gave my word that I was going to split, I would split. And you're going to take steal. So
The only way you can guarantee to walk away with 6,800
it's by
is to
sharing.
guarantee that you both put the split ball in. And I do now have to push you for a decision. It's a tough one.
We've lost it. We've lost everything.
Okay. Last then.
We're walking away with no money because you're an idiot.
No, that's
You're an
not.
idiot. You're an idiot. That's what's right. You're an idiot. You're an idiot. That's what you are.
This can go on all night, and these people have got to get up for breakfast. Nick, choose split or steal. Ibrahim, choose split or steal. Now, please. Choose a ball.
Right, I'll tell you what, I'm going to go with you.
Okay.
I'm going to go
I
with you.
promise you I will split it.
You cannot change your balls now. Split or steal. Yes, congratulations.
Okay, what happened? The brown guy is going to split, but why did he just steal? Why?
Because he didn't want the other guy to walk away with this. He made sure that he both of the things.
Right, exactly. Because he wants to force the other guy to split. Because by taking the option of other guy, he actually did and forced him, and basically the other guy was a reasonable guy. He would have actually done, I would say, steal. But let's the other two. But he didn't split basically because he wanted to split right away. Now that he initially said that I'm going to win first and I'm going to split after the game. That's not what he did. He split right at the game. So, but then why did he do this? He's a reasonable guy, but because basically he actually was forcing the hand of the other guy to do split. What if you don't do this? We'll see next one. Okay, is this clear what's happening here?
The other guy can proceed. The other guy can put speed and by denying them everything or he would take everything.
Right? So now what happens is let's see this guy, the brown guy forced the hand of the other guy to do a split. Now we'll see another game. Basically it's the same game but with two different people and you'll see what happens here. Okay, are things clear here? What happened here? Do you understand what happened here? So, okay, now let's look at the next one.
Final winning golden ball for today is.
Can you hear what's happening?
How many times has this happened to us?
So,
I'm very happy.
That's extremely.
so
Your jackpot for today is £40,015. The question is now, can you keep?
sorry, are you able to hear? Is the audio no, not working? Volume, okay. Try something.
Spin it, Tracy, spin it.
Volume, we're having a problem here. I think the volume is not audio. So in this game, what happens? They have about 41,000 pounds with them right now, and now they have to play the same game. You know the rules of the game now. All of you experts now. So now we'll see what. And now you have to say what happens. So what I do is before they take a decision, I'll ask you who is going to split, who is going to steal, or what. Everybody will. You can tell me what beforehand. Okay.